Hey everybody, we're back. Chapter 15, Part 3. And this time we start looking at the shortcut method. I'm not a real big fan of the shortcut method, but it works. So, the shortcut method. Rowdy's being a big baby if you hear him. He's wanting me to play. He doesn't understand I can't play. Okay, the rule for the shortcut method is we're going to take whatever we have, our rate in milliliters per hour, and we're dividing it by the drop factor constant. And our answer is going to come out to be drops per minute. Okay? We're just taking that big shortcut of doing all the conversions. I don't like it because it doesn't show how we get rid of the milliliters per hour and go to the drops per minute. Hang on. Alright, so back to the drop, or the shortcut method for the drop factor. When we do this, one of the reasons it works is that if I have a drop factor of 10 drops per milliliter, and I multiply it by 1 milliliter per 60 drops, or 1 milliliter in 60 minutes, because it should be milliliter per hour. Instead of putting hour, I'm putting 60 minutes. My milliliters cancel, and I get 10 drops per 60 minutes, which gives me 1/6 of a drop per minute. So if I was to take this and take my milliliters per hour over my drop factor constant, I'm actually going to have milliliters per hour divided by the 1/6, which is the same thing as the milliliters per hour times 6. That goes back to our fractions. That's the reason this works. So my constant, my drop factor constant is equal to 6 for 10 drops per minute, or 10 drops per milliliter. Okay, so the drop factor constants, and I could do this with each one, but I'm not going to bore you. Y'all don't care how it works, just as long as it works and you know how to use it. So we have 10 drops per milliliter. Our constant is 6. 15 drops per milliliter. Our constant is 4. 20 drops per milliliter. Our constant is 3. And 60 drops per milliliter, our constant is 1. We're going to get the same results on these as if we had worked them in the long way, or doing the drop factor constant if we'd worked them in same way we worked them in part 2. So example 17, no, that's not right. Yeah, I guess it is right. I am on 17. The order is D5W, 1,000 milliliters IV at 125 milliliters per hour. And I have a drop factor of 10 drops per milliliter. So, according to my rule, and I'm wanting drops per minute, I'm going to do the milliliters per hour over my drop factor constant. So my milliliters per hour is the 125 milliliters per hour. My drop factor constant goes back up here, and it's 6. So I'm going to divide it by 6. 125 divided by 6. Because remember that milliliter per hour goes away when I'm doing this. And I get 20.8. I would round it to 21 drops per minute. But if you leave it at 20 drops per minute, we're okay. So it's an either or situation there. But it has to be one or the other. Maybe I wasn't at 17. Maybe I was at 13. I don't know. All right. So still using, let's do another one, still using the drop factor constant. And this one is number 14. Excuse me, papers are coming apart. So example 14, I have an order of lactated ringers, 1,000 milliliters IV at 150 milliliters per hour. And my drop factor is 15 drops per milliliter. Okay, so I've got, what do I need? I've got the 1,000 milliliters, but I've got a rate. Anytime I have a rate, I don't need the total volume. So, using the drop factor constant, using the rule, and I want drops per minute, I'm going to do my milliliters per hour divided by my drop factor constant. So my milliliters per hour is 150 milliliters per hour. And if we look back at the other page, our drop factor constant for 15 drops per minute is 4. So I'm going to divide it by 4. That will go away. I have 150 divided by 4. And I get 37.5, which would round to 38 drops per minute. Or again, you could give me 37 drops per minute, as long as it's a whole number. Okay. So the next thing on the worksheet, or the handout, is adjusting the flow rate. So when you go in, if you've ever been a patient or visited someone and you hear all those beeping where their machines quit working for some reason or another, they've got the IV in the crook of their arm and they bend their arm and it crimps the IV tubing, or if maybe it gets caught somewhere else and it gets crimped and it's not flowing. Well, this happens with the manually regulated IVs, and I'm sure it happens with the others, but I know it happens with the others, and I know it happens with these. So we're looking at the adjusting the IV flow rate, and this is example 15. So what you've got to do is, if you've ordered to give so much, or a volume of an IV for so many and so much amount of time, then you've got to make sure that IV, because a lot of times it'll have medication in it, and they're trying to get that medication in a certain amount of time. So you got to make sure that IV flows. So my order is D5W, 1,000 milliliters at 125 milliliters per hour for 8 hours. The drop factor is 10 drops per milliliter. So when you go through and you're checking it, you know that the IV is correctly set at 21 drops per minute. Either you've started it or somebody else has started it and you've checked it, so you know it. This is our original flow rate. Okay, so when it's correctly set at that rate, that's our original. So if we're going through the change of people, or you're making your hourly checks on the IVs, this one does say during your regularly IV monitoring, at the 4th hour after starting the IV, you find 600 milliliters remaining. So we know that after 4 hours, because at the 4th hour means after 4 hours. So this is the 4th time you checked it. After 4 hours, you have 600 milliliters remaining. So what you want to know, well, let me finish reading the problem. It says a hospital allows a 25% IV flow variation with careful patient assessment, and if the patient's condition is stable. Our patient is stable. And it says calculate the adjusted IV flow rate and determine if you can adjust the IV. So what's the difference? If we look at this, after 4 hours, it's running for 8. After 4, that's half the time. So I should have 500 milliliters run through the IV because I've got 1,000 milliliters to start with. Well, I've got 600 milliliters that have already gone through. So it's running too fast. So I know I'm going to have to slow it down. So we're going to look for the new flow rate if I were to get to adjust it. Some people call it the adjusted flow rate. Same thing. So this is taking the total remaining fluid and divide it by the total remaining time. Times our drop factor times our time change. So, and I read that wrong. Oh yeah, there's 600 milliliters remaining. I should have had 5. I've only had 4. I read that wrong. So it's running too slow instead of too fast, but it's definitely not running at the right rate. So my total remaining fluid is 600 milliliters. Don't necessarily care about what's in my order. After 4 hours, let's write down 600 milliliters. After 4 hours, how many hours am I going to have remaining? I started with 8. 4 hours later, I still have 4 hours remaining. Times my drop factor, the 10 drops per milliliter, and then times my time, my time conversion. So, hey, 60 will go into 600 10 times. And then my milliliters cancel, my hours cancel. And I have 10 times 10 over 4, which is 100 over 4, which is 25 drops per minute. So that's my new or my adjusted flow rate. Okay. Now, in order to determine if I can adjust it, I have to find the percent of variation. Okay, and to find the percent of variation, you're going to take your original flow rate minus your new or adjusted flow rate and divide it by the original flow rate. And I got that backwards. It's the new flow rate minus the original. I knew something was wrong when I did that. So my new flow rate is 25 drops per minute. My original is 21 drops per minute. And I'm going to divide it by 21 drops per minute. Since they're all the same units, I don't have to worry about putting the unit there. So 25 minus 21 is 4. Or 21, so I'm going to divide by 21. That equals 0.19. I'm going to times that by 100 to get my 19%. So my 19% is less than the 25% that is allowable. So I can adjust the flow rate to the new flow rate, which is 25 drops per minute. Okay, we're going to do another one of those. When we come back, because my time is running too long.